Well, welcome everyone to the 2010 Dayton D-STAR Forum. Good to see everyone here. My name is Greg Surratt, W4OZK. I think the crowd gets bigger every year. It's good to see a lot of friends and people we talk to on the air. At this forum this year, we have Robin Cutshaw. He'll be up first. And then David Lake, G4ULF, talk about his homebrew D-STAR repeater. And Dan Smith, KK7DS, will be this morning. Many of you have probably already been by the D-STAR booths outside. There's a D-STAR on-site repeater hosted by the Georgia D-STAR group, 440-725, call sign KJ4BDF. And then the local Dayton repeater, 145-27, minus offset. Tonight at the jury end, the Friday night D-STAR hospitality event meeting at the jury end over on Miller Lane, 6616 Miller Lane. Drop by the D-STAR booth if you'd like directions, and the Georgia D-STAR group is hosting this year's event. A little extra treat from you guys this year. I'm not going to talk other than invite these guys, introduce these guys. So we'll get right to Robin Cutshaw, AA4RC.
Good afternoon. I'm Robin Cutshaw, AA4RC, and I'm a D-STAR holic. It's been about 5 minutes. Wait a minute. 3 seconds since I last keyed up on D-STAR. If you're not to that point yet, you will be. D-STAR is very addictive. The other thing I should say to open this is remote system linked. Now, for those of you that are new to D-STAR, that's an inside joke, and you'll have to talk to somebody that was just laughing to figure out what that was all about.
They can't hear you.
They can't hear me. I'll lean in. Is that better? Remote system really linked. Okay, today we're going to cover a lot of information in 30 minutes or so, so we're going to rush through this. There will be a test. Unfortunately, most everybody fails the test, so I've given this the last 3 years, the first couple of slides, and we're going to see how many people pass this year. First, we're going to dazzle you with digital, all things digital, and then bore you with bits. So there's the information that you need to glean, and this is what the test is on. The key to take away from this mostly unreadable slide is that that's all ones and zeros. And there's a red part and some green and blue there you see, and then some blue there on the bottom line. That's all D-STAR. That's what D-STAR is. When you key up your radio, in fact, this is a kerchunk. I just keyed up real quick, and that's what comes out. That's all the ones and zeros that are sent via GMSK protocol from your radio to the repeater or the repeater to your radio. So when you're talking analog into your HT or mobile radio. I guess soon we'll have a base station. I hear some rumblings that there's something over in the ICOM booth that will be interesting to see. But you're talking analog into your radio. Your radio is converting that with a vocoder, a chip that takes the bits that are this long when you talk and making them this long and putting them in a special D-STAR format. And that's really what D-STAR is. It's a protocol definition of where the bits go and what they mean. So I key up and talk. The vocoder chip is taking those bits and converting them to digital, so a little small bandwidth, adding data to it. So when you use your radio, you have to program in my call, your call, repeater 1 and repeater 2. That's kind of the mantra of D-STAR. My call, your call, repeater 1, repeater 2. my call is my call sign. Every time I key up, I'm IDing. So I don't have to voice ID anymore because every time I key up, it's IDing. Your call is who do I want to talk to? Do I want to talk locally, in which case I'd put CQs in there? Or do I want to talk remotely, somewhere around the world? Do I want to do a call sign route to somebody in Sydney, Australia? Do I want to talk to a repeater, and I don't care who it is in Sydney? Or do I want to link into another gateway or reflector? All that's done through that one 8-character field, the your call field, of what I want to do with it. And that's one of the benefits of D-STAR and the digital protocol, is I can now command it to do all the things, and just anything we can think of that we need to do, we can program on the repeaters, on the gateways, the reflectors, to take our commands and do what we want with them. So we've now talked into the radio. We've got D-STAR bits that are all here. The red is the header. That's where my call, your call, repeater 1, and repeater 2 go. So there's 660 bits there that make up all of that information. And it's got forward error correction and all sorts of technology there so that when you take bit hits, static hits, that it can recover from that. And then the green portion is when I keyed up. Every 20 milliseconds, there's green streaming out. And then there's 3 bytes of data that goes along with it. That's the blue that you see there. So the real test is what does red, green, and blue mean? That's header, voice, and data. And then at the end, you see some more blue, and that's the end that says this is the end. When you hear your radio beep, that's because it got that blue at the end. That's what it's telling it. That's what the header actually looks like in the protocol packet. So you see there's some flag bits to say, okay, this is for a repeater, or this is for a user, or this is an emergency. You can go into your radio and set an emergency bit that will basically tell other radios that are turned down to turn themselves up, that this is an emergency. So you have the power to make all those people that are asleep, that have turned their radio down, wake up just by setting that one feature in your radio. And that's all in the flag bits. And then repeater 1 and repeater 2 are routing information. It's like, how am I going to get to my local repeater, and where do I want it to go from there? That's what the actual format looks like, the D-STAR. And I know that that's really readable from way back there and probably not even readable from up here. But that's all of that red and green and blue. That's in that frame right there. So you've got the flag bits, the sync bits, the header bits, the voice bits, and the data bits. It's all defined in this open protocol. And it does some special things with that header, as I mentioned, to scramble it, interleave it, do convolution, things that satellites do to try to get better data out of it so it can try to recover when there are hits to the data or fades. And once it's gone into my radio and it's been encoded as those bits that you just saw, it gets modulated as GMSK, Gaussian minimum shift keying. And that's similar to FM, but it's just enough different that some FM repeaters will pass it and some won't. There's more information that you need down in the low end. A lot of repeaters filter out, FM repeaters filter out the low end. So some repeaters may actually pass your traffic if they've got a wide filter on it. But it's not going to do anything because an FM repeater wouldn't know what to do with the bits. DPLUS is a program that we wrote that took that information that made it now from the radio to the repeater to a gateway computer, which is a Linux box running at each repeater site. So we now have the digital data in an Ethernet IP format, and we can do stuff with it. We can figure out what it looks like, and we can take all those commands and do things. And I wrote this program, DPLUS, which is kind of a Swiss Army knife addition. One of the features that I was used to on an FM repeater was echo test. Am I making it into the repeater or not? Well, D-STAR didn't have that capability. So one of the first things that DPLUS did was echo test. So now I can put in the your call field an echo test command and key up, and it'll repeat back what's there. There's also an ID command, so I can have the repeater ID itself back to me. So just using those two, a repeater admin can go in and see, is it hearing and is it transmitting well? Which has been a very valuable tool for repeater managers when they're first putting up their system to see how far are they getting out, where are the fades, where are the hills, where are the problems. They can just drive around and run those two commands and figure out, is the repeater hearing me, and can I hear the repeater? There's several other features that were added. Simulcasts, so I can be on 2 meters and tell it to also go out on 440 and 1.2 gigahertz. Script execution, I can now put a your call in that says run script A on the server, and script A may go out and get a emergency weather bulletin and then encode it as text or voice and send it back to my radio. And since it's digital, if I've got a PC or a dongle plugged in, I can actually see all of that emergency weather text that just came out as a result of me asking for it. You can record and play back voice data files. So if you want to create files for your repeater or for your dongle, your DVAP, you can go in and use those recording and playback features to do that. It's one of the cool features that we did for our club, the Atlanta Radio Club, that put up the first D-STAR repeater in Georgia, is we had every member of the Atlanta Radio Club that had a D-STAR radio go in and record, W4DOC digital repeater. And that's all they said. And their call sign was in that because it's in the data stream. We saved every one of those files, and so we would have 20 users that recorded that information and wrote a little script that every hour it goes out and plays one of our members of the Atlanta Radio Club saying W4DOC digital repeater. And that was a big hit. That gave them pride in their club. So that was one of the features we were able to give back to our members, is the ability to have their voice saying the ID once or twice a day along with all the other members. We then added the ability to link the repeaters together. So now I can have W4DOC in Atlanta connected to K6MDD in San Francisco, and all of our users can talk back and forth to each other. I then wrote the reflector software that gave us the ability to link a whole bunch of systems in. And if you look at the webpage ref030.dstargateway.org, you'll see that there's 60 or 70 repeaters from around the world currently linked in, and probably about the same amount of dongles, DVAPs, hotspots that are all there on 30B because that was designated as the Dayton reflector, the Dayton place to be. So people from around the world are listening for what's happening here in Dayton by just connecting in using that your call field to link into reflector 30B, and they can all talk and ask questions and hear announcements that come out. And then that gave us the ability to create a new little device, the DVDongle. That chip that's in all the radios that takes your voice and takes it from this size to this size is from DVSI. It's called the AMBA 2020 or AMBA 2000. And that's the only proprietary part of D-STAR. This is not an ICOM specific technology. ICOM chose to implement it, and we should thank them because they have made D-STAR possible. It's an open protocol, though. Anyone can implement it, but they have to buy that one chip from DVSI. And some people complain that, why did you pick a proprietary chip? But DVSI is the leader in the industry on being able to take those bits like this and put them right there, transfer them, get them back into this, and have it sound correct. They just do that better than anyone else in the world. And in fact, APCO 25 is based on DVSI technology. If you talk through Inmarsat, a lot of the military satellites, they use DVSI technology. So it was really a wise choice because that gave us the best voice quality in that very small packet format. So we took that same chip and put it in the DVDongle, and with a USB interface. By the way, there's a blue DVDongle somewhere around up there. And by the way, the blinking light, that's the BINI Buy me. Buy me. Every time you see that blink. And of course, I have nothing to do with the company that makes the DVDongle. It connects to your laptop or PC and gives you access using the microphone or speakers of your PC to that international D-STAR web network. So now on my netbook, I can connect in using the internet with the dongle, and I can listen to and talk to everybody around the world. So with the dongle, you can now take your laptop on the road with you, and you can connect into your home repeater or any other repeater that's on the D-STAR International Network and listen to and talk to the folks that are on that repeater. And that was initially thought of something that admins would want because you can go in and listen to all the frequencies at the same time, listen for activity on your home repeater. But then we found that users wanted to be able to use it and connect in, especially road warriors. It's really big for that functionality. And in fact, I took its big brother, the red box that we'll talk about in a second, in my netbook, in my Verizon Air card, and put it in my Durango, drove up here from Atlanta to Dayton, and the entire way, except for a little stretch of the mountains of Kentucky, I had internet access, and I was talking on D-STAR repeaters and reflectors from around the world the whole way. So I didn't have to worry about programming in repeater frequencies or looking for a repeater. There's 3 or 4 repeaters between Atlanta and Dayton. And so there would be a lot of area that I did not have coverage. So that gave me the ability to talk on D-STAR and to be able to key up every few minutes, which is kind of a requirement. And okay, this is the software, the latest. This is 2.0 beta 4 software, which if you have a dongle, everybody should be running this version because it's the most stable and has the most functionality. And basically, we can go in and we open the device. It just went out using the Verizon network, which I have that air card in my netbook right here, and connected to the name server and said, give me the names and IP addresses of all of the gateways and reflectors around the world. And just in that little blurb, it sent it down, and that came from the server saying, okay, you're running the latest version. Thanks for doing that. So it will always tell you from the server side whether you're running the latest version or not, so you'll know how to go and upgrade. And then here is a list, if you can see it, of all of there's Germany and Great Britain, and you can see all of the repeaters around the world. Those are all of the repeaters you can connect to, listen to, and talk with folks from around the world. And that became a little onerous to always go in and try to find your favorite repeaters. So we added a favorite repeater feature. So now you can make your own list of repeaters that you connect to and talk to. And let's connect to reflector 30. See if we can do a live transmission to reflector 30. And module B is the place to be this weekend. And there's people talking. And if I turn up my volume, maybe we can hear it. Okay, now we should. It's probably hard to hear this, but that was somebody just on there. Let me do a quick shout out. This is AA4RC transmitting from the D-STAR Forum at Dayton 2010. So I just went out and transmitted using the mic on this to the 50 to 80 repeaters and 50 to 80 dongle DVAP hotspot users that are connected into the reflector 30. And I can go in using the software and query it. So I just asked the gateway, or actually reflector in this case, to give me a list of everything that's going on. So you can see in this list, those are all of the gateways that are currently linked in. These are all of the DVDongles, DVAPs, and hotspots that are currently linked in. And then this is the last heard list, and you can see I'm at the top of the list because I was the last one. And the history tab lets you see every time somebody keys up, you remember the mantra, my call, your call, repeater 1, repeater 2. Well, those are displayed here. So every time anybody around the world is keyed up on one of the systems that's linked in, I see all of that information and the timestamp. And folks that run nets use this because you can save this display to an Excel spreadsheet. And so you run a net, you talk to folks, then you go save the file, and now you have a list of everybody that checked in the net. There's also a data tab. I told you there's data bytes in the D-STAR protocol. This is data information. That's actually GPS information that came from one of the guys that keyed up. There's a couple of ICOM radios that have GPS built in.
Are you going through K6SOA or are you going through the Whiskey 8 repeater?
So they're trying to figure out where they're coming from. So you use one of those GPS systems, and now you can see the GPS stream. Or if people are typing text messages, you can see those text messages here. And let's disconnect here. And then you can always go in and customize it. Let's see, there's Connie's favorite. Connie, are you here? KB0ZSG, this was for her. This was pink and blue. And this is Mark, KJ4VO. You've probably talked to him. This is what he uses because it has the highest contrast, and he can read that the best. And I tend to use this one because I like blue. Anyway, that's DVTool and the DVDongle. So last year here, we announced something new, the DVTX dongle. And it did the same thing as a DVDongle, except it transmitted on 2 meters. So you could listen to the conversation, but you couldn't transmit. It only worked half the distance. So since that time, instead of coming out with that product that you could only receive on, we came out with the DV access point dongle. And it has a full 2-meter transceiver built into it, plus GMSK modem and USB interface. So now, I plug this little blinking, remember the blink, device in, and using my D-STAR HT, I can get my fix anywhere I've got internet access. And that's the device I was using all the way up from Atlanta with my radio to talk on repeaters and reflectors around the world. So you now can either use your PC without a radio or your PC with a radio. And those are various configurations. You can see it has an SMA connector. So natively with the little antenna, you probably get 100 plus yards out of it. It's 10 milliwatts. It's meant to be a local access point. If you plug it into an external antenna, something outside in the yard, people are talking about 1 to 2 miles that they're getting.
Adrian, I think, got almost 15. He's 800 foot above.
Now, if your line of sight, if you put it on a satellite, you might be able to get a few more miles. So as I say, it's got a 2-meter transceiver, 10 milliwatts for roughly 100 yards. And what you need is your PC. I'm using a netbook here. You need an internet connection and a USB port, and of course your D-STAR radio. And you have to use a D-STAR radio. This doesn't replace the dongle. So if you want to use it with your speakers and mic, you would buy the dongle. If you want to use it with a radio, you use the DVAP. And I think we're running a little low on time. Feel free to come by the booth. There's really not much to the demo because this was designed to, you connect to it, in fact that is the demo. You connect to it and you walk away from your PC. And now you do all your commands. All of the stuff that I did on the repeaters using DPLUS, the linking, the echo test, the ID, the exact same commands are used from your radio. So now you're not tied to sitting down in front of your PC. In fact, folks have been coming up saying that there's several set up in their hotel. So now you can go anywhere in the hotel that they're staying in and get access to the D-STAR network and talk to all the folks that are on 30B right now. And now for a few surprises. How many people have a DVAP already, a DV access point? Wow, a lot of folks. Well, you're going to be happy because we have a few surprises. We've added a band scanner. So you want to know what frequency should I use on my DVAP? What's open, what's currently, who's keying up on other frequencies around, what repeaters are around. We now have another piece of code, and that will be integrated into DVTool shortly. This is a standalone piece of code that you connect to, and you can see the entire 2-meter band there, 144 to 148. And it'll show you what's there. And you can make your decision as to what legal frequency that you should be able to connect to. The other feature of this tool is the ability to adjust the frequency calibration within the DVAP. Some folks that are in hotter or higher altitude locations are seeing that their frequency has drifted up or down. And so with this, you can go in and calibrate your frequency to be exactly dead on. This tool also has a firmware updater. Unlike some manufacturers, and we won't talk about those manufacturers here, we will let you update your firmware yourself. You don't have to ship it back to the manufacturer. That was not a cut on any manufacturer that's currently at this show. I love all the manufacturers that make D-STAR. The next thing that we've added is the functionality that was already on your board, but we hadn't updated the firmware to use it. And this is a picture of the board that's in the DVAP. And that little section right there has 4 places on it. It has ground, plus 3.3, plus 5, and a TR switch. So now you could actually route that out and plug a preamp or an amplifier in it and have the DVAP control that external device. In fact, there'll be a demo tomorrow morning that hopefully is working, that we've got a lava lamp out here in the booth. The booth is right outside the door here, and we're going to show the lava lamp going on and off when you're transmitting on the DVAP. So you don't have to plug in an amplifier. You could be creative. And that was all Mo's idea. By the way, AE4JY, Mo Wheatley, is the designer of the hardware, and he is a hardware genius. And when I say, it would be nice if we had a device that, and then, a month or 2 later, he says, is this what you mean? And that's how both the dongle and the DVAP came about. And the one last feature that we've added is FM capabilities. So now you can use your DVAP and your radio in FM mode and talk to yourself. We have demo software that allows you to record and play back and do simplex things, and the intent is to take the FM mode and tie it in to the rest of the world. So maybe we're able to connect into the Echolink network. So now you've got a DVAP you can use on Echolink and D-STAR. Or maybe we have a module that plugs into your local FM repeater, and you could use your DVAP the same way that you're using your DVAP or dongle to get into D-STAR gateways. So that's all. It's nice to be able to talk to yourself. We hope to add more functionality out of that device. It's new firmware. If you've got your DVAP here or you're buying one here, come by the booth, which is right at the top of the audio hall, and we'll reflash that firmware for you here. We'll probably release that firmware this week, but to give those people that have them here or buy them here a little benefit, they're going to be able to get it early here in the booth. Any questions? I may or may not have answers. Okay, I'll repeat the question. So yes. I wrote DPLUS, the reflector software. Within the next week, there'll be updates to both of them. I've added some new features. The number one support question that we get right now is, am I registered? And how do I find out whether my registration that I did 3 years ago is still good? There's a website you can go out to and look that up. We've added that to the DPLUS protocol. So the next release of the dongle and DVAP software will let you go in and it'll tell you whether you're registered or not. So you'll be able to very easily see whether you're registered, and you have to be registered to transmit. Anybody can receive, you have to be registered to transmit.
I'm just curious, what's the point of a computer coming up at 6:05 in the morning and forcing all the Atlanta repeaters to be linked?
You know, some people like linking, some people don't. The admins of each repeater can select what they want to let their local users do or not, and whether they want the systems to link or unlink. So that's one of the nice features of DPLUS, is that the admin has complete control over all of that functionality.
Robin, I have a question on the operation of DPLUS. In our experiences in the metropolitan DC area, we find that we often have new users coming into the D-STAR system, and a number of times they either forget or they don't know about a busy channel lockout, and what they're doing is crushing headers and thus killing the entire D-STAR system as it speaks. Is there any type of technology you might be able to come up with in the near future to address that situation and follow it up, possibly by having some sort of acknowledgement from the repeater that you are getting through to that particular repeater? We'll have a net on a Sunday night, and some of our users will not know a clue about busy channel lockout, and they'll jump the gun and they'll just crush headers, and then we're sitting with dead space.
That's a very good question, and that's something that every D-STAR radio owner should do, is set that busy channel lockout so that you don't stomp on somebody when you key up. Your radio's listening for the carrier and won't let you transmit. Unfortunately, if you're on the same local repeater, there's nothing you can do if you don't have that set. There are some enhancements that I hope to make to DPLUS that will keep you from transmitting from two separate systems at the same time.
Robin, when we link, run link, we see your call sign, latitude and longitude come out of the repeater. Can we customize?
Remote system linked.
Yeah. Can we customize that to have our own repeater call sign and maybe the latitude and longitude of that in the DPLUS software?
Absolutely. In fact, I hope that you do. It wasn't my intent to have everybody in the world listen to my voice. Using the echo command in DPLUS, it will actually record the file. So just like we had all of the Atlanta Radio Club members, when they just ran an echo test and talked, it created a file. You rename that file to the same name as what's coming out. So there's a file there called remote system linked. And you rename the echo file to remote system linked. Now it's your voice and your call sign and your lat long coming out. So you're in complete control of that.
Robin, I just had a quick question. If you had any update on the Open Gateway project that you had kind of started a while ago.
We have some activity that is happening on that now. We're going to make an announcement about that very shortly, but it's not quite ready to make an announcement about. But it's in process.
I still have a question concerning when you either link or unlink, to have the repeater report back of the call sign that you linked to.
Absolutely. That'll be a feature in the next version of DPLUS. Just like when you're on the DVAP software, every time you key up, it gives you the call sign of where you're linked to. The next version of DPLUS will also, when you link, it'll give you back the call sign of the reflector or gateway.
If you use the identity call command, will that also, if it's linked, report back who it's linked to?
It reports back now that you're linked. That next version will actually give you, in the text message field, the name of the repeater reflector you're linked to. We should probably only take one more because I think I'm encroaching on other people's time here.
Hi, Robin. This new open source you have for the Gateway project, is this going to be able to support any other boards besides like the Satoshi board, or are we going to be stuck with the DSense boxes from ICOM?
It will be open. In fact, we've already got, if you come out to the booth out here, there's a Georgia D-STAR, D-STAR Info, Internet Labs, DVDongle, all along Audio Hall. You'll be able to talk to David Lake, who's coming up next to talk about his technology. And he's got it here, and it is not from ICOM, and it is operating as a gateway on the international network. So that's an excellent segue to...
Robert, I have one question myself.
Yep.
Do you plan to add capability to DPLUS so that more than one repeater at a site or at a gateway can connect to the same reflector at the same time?
More than one module?
Yeah.
Yes. That's also on the enhancement list. And in fact, one of the biggest requests is I want to link all of my modules for my local net, and that'll be there as well. By the way, there's just one more thing. I don't know whether you can see this. It's the DVAP is a QRP device. It's 10 milliwatts. You can't make a QRP device unless you have it in an Altoid scan. Come by the booth and you can see it actually running in the Altoid scan.
There we go. That's the right year. Okay, so I'm Dan Smith KK7DS, and I'm the author of DRATS, which is a piece of software for data transfer over your D-STAR or other radio. So initially the goal was to be kind of an all-in-one, can I use Swiss Army knife? Swiss Army knife for the client side of D-STAR. Use that 900 baud data carrier for something useful. I was looking at specifically MCOM type applications, and I didn't want to be dependent on any infrastructure because I don't typically like people saying, well, when the hurricane hits, we're going to fire up our internet browser, and right. So I didn't want it to be dependent on any infrastructure, which means needs to work over simplex, and your machine has to be able to do everything. So there's no server version of DRATS. If you have DRATS, it can do everything that you can do with DRATS. And then I put this in blue because this is what's different from last year on this slide, is that I wanted to interface with existing technologies, technologies that are 2000 and later. So changes in version 0.3, which is since the last time I was here. A new user interface. It looks like an email client when you're doing messages. It looks like a FTP client when you're doing file transfers, that kind of thing. Message routing, I don't know if I even discussed this at the last Dayton as an upcoming thing, but now you can have multiple DRAT stations and have messages automatically forward between them, and it will do a little bit of that for you. If you can't talk to somebody local, but you can talk to someone they can talk to, you can just send a message to the intermediate station and it'll figure it out. Multiple ports, I don't know if I mentioned this as a possibility the last time, but now you can connect a UHF and a VHF D-STAR radio to it at the same time if you want. Be on two different bands, gateway messages back and forth between the UHF and the VHF people. Do that. You can connect TNCs to it, so if you don't have a D-STAR radio but you want to play with it or don't have any desire to have a D-STAR radio, you can use KISS mode TNCs connected to it, and it doesn't make it transmit D-STAR, of course, but it just uses that as the modem to get on the air. And then, of course, network connections. So the whopping 3 people that raised their hand were talking about using DRATs over the network. There's a Ratflector that I run where you can connect in, and it kind of looks like a shared RF channel over the internet for everybody to play with and send each other files and do that. So KISS TNC, I mentioned that, and AGWPE. I have like this much AGWPE support right now, which allows you to use a TNC that you can only reach, via AGW, or you can actually do some connected mode AX25 stuff for WinLink stuff. And then there's also a plugin API, which I spent a lot of time working on, and only one guy wrote a plugin, so. But he actually uses it to grab DX spots and sends it over his D-STAR radio so that when he's in the field, he can see his DX spots, which seems kind of crazy. But so messaging, this is mostly the same as last year. Not a lot has changed here. There's kind of two components in DRATs. There's the chat messages, which kind of looks like IRC or a group chat. It's checksum protected, so if you send a message, if it gets displayed on the other end, you know it's actually what they said, and that the nuclear launch codes weren't garbled a little bit. It doesn't do ACK-NAC. It's kind of a broadcast, best effort sort of chat thing, but it works pretty well. And then new recently is this concept of a chat room or a private chat. So you can go and create a new group and, you know, Georgia D-STAR or something like that. And everybody that wants to can join that group, and then only those people will see the messages that you are sending to that group. So it works like a little chat room. Or a private chat, and I put private in quotes because it's not private at all. But it allows you to direct a message directly to one other station so that theoretically only that person is seeing it, but it's not private. So that's chat. The other kind of section of messaging that it does is this. I have a real hard time coming up with the right word for this. I used to call it forms and then structured messages, but it's basically email. It's like email, except that you can define forms, right? So there's an ICS 213 in there. There's a radiogram. You can create your own forms in there that gives you the ability to pop up a new ICS 213, fill it out with all the fields, and then send it off to someone else. So that's been in there for a while. Now you can attach multiple files to a message. So if you're going to use the message routing to get a message from one end to the other, you can attach some files to go along for the trip. The automatic message routing, like I said, and the new kind of email-like interface. So I don't remember if what state this was in at the last Dayton, but there's now an email gateway which allows you to have one station that is connected to the internet that other people can reach over RF. You can send a message to an internet recipient and send it through that station and have it gateway it out to the email system for you. And likewise, you can program in a POP3 server setting and say, I want that guy to check my mail for me, and it'll download any messages that you have and then forward them over D-STAR to you. So you can be, reasonably connected just over RF without an internet connection. The other kind of big thing is a WinLink 2000 gateway. So you can ask an internet-connected station to check my WinLink mail for me. And since we can make some assumptions about the WinLink system, your call sign is your email address, that kind of thing, it's pretty easy. You just right-click on a station in the sidebar and say, check my WinLink mail. And it will reply with no messages or 2 messages or whatever, and then forward them to you. Additionally, you can send a message out to the WinLink system through another station. And that way, if you've got one station somewhere that has RF links to multiple people and has an internet connection, those people then, with just the existing D-STAR equipment that they have, get and send WinLink messages. There is an experimental RMS packet client built into it, which has a lot more experimenting to go, but if you have an AGW connected TNC, you can actually have it go out over connected mode AX25 to an RMS server and do all the same WinLink stuff that you can do over the internet connection. So, theoretically, you could have a RMS relay station with an HF link and the VHF part, and then distribute that to the whole D-STAR network that's within range of you. And then something I just added in the latest beta is this SMTP and POP3 server, which allows you, if you would like to do that, use an email client instead of DRATS itself for the messaging. So you just set up, Outlook or Thunderbird or something connected to localhost, and you can get your DRATS messages and send DRATS messages, kind of like Packlink does. So that's the new interface there. You see the messages tab kind of looks like an email client. Got folders on the left, messages on the right. That's what a new email message looks like. There's a little attachments thing down there that you can attach files with. And this is an example of a radiogram. If you create one of the more rich forms, this is what the printable version of that looks like. This is a HICS 260 form, which is, I just have to keep showing it because it took me a long time, but that's like exactly what the actual paper form looks like. So you can send just the data across the D-STAR link and then present that at the end and print it out for your hospital or whoever's expecting it. So in addition to the messages, there's file transfers. You can transfer any kind of file as long as it's small enough to fit within your patient's window. The new interface has a kind of a file server type of thing built in. So it looks like an FTP client where you see your local files on the left and the remote files on the right. And so you can see what they have, download something, upload something to them. Makes it considerably easier. If you're uploading an image, it brings it up in this image tool here. And that slider there, you can just drag that back and forth until it's grainy enough to be small, but sharp enough to get the point across. And that helps you not have to open a 5 megapixel image that you just got off of your camera in Photoshop or something and resize it. And it now does block size and window scaling. So if you've got a really solid connection to someone, it will start to figure that out as you're transferring a file and start making its window bigger and its blocks bigger so that it increases performance, keeps the radio keyed longer every time around. So this is what the file transfer interface looks like now. I was on the plane, so I didn't have a real quick way of filling in the stuff on the right, but if I was connected to another station, you'd see their files on the right there, local files on the left, and then you can just upload and download. For a long time, I've had maps built in and a mapping client so that you can see all of that data that's coming across from the $600 92 that you bought. So you just do view maps in the program and it pops up and it downloads the maps off the internet, caches them on your local machine so that you can see the other stations as points on the map. The coolest thing that you can do with this, I think, is get somebody going at like 60 or 70 miles an hour on the highway, get them to key up and talk, and you'll just see them in real time shooting across the map while they're talking. It's really cool. So that's what the map window looks like. You don't have to buy maps or download maps or do anything. You just say view map. That's what you get. It uses the OpenStreetMap free mapping project to get all its data. You can overlay multiple, I guess I should go back. You can overlay multiple things on the map. You see some real stations here as well as some of our fire stations and hospitals. You can load in a CSV file with a whole bunch of map points and icons on it so that you can pre-load the map with points of interest. So those are kind of static points. You can also tell it buoy numbers of the National Buoy Data Center, because I think that tells you something before the hurricane comes or something. Yeah. So unfortunately, this is a picture. So oh yeah, there you go. So if you mouse over it, it'll show you all of the data from that buoy, and it refreshes it regularly, so that you have to have an internet connection for this, but someone that's interacting with other DRATS users can be monitoring this and can also broadcast the positions and some of that data to some of the other stations on frequency. In addition to that, I don't have a screenshot of it, but there's also a river type of map point. So you guys have, well, not you guys, but the guys down in the southeast, they have the hurricanes, right? Well, we have rivers, and they like to get all high and mighty every once in a while. And so you can actually put the river level monitoring stations on here as well and see the river heights. The RATflector I mentioned is an internet. It works kind of like a reflector for D-STAR voice, but it's data only. Doesn't require anything blinking or anything like that. Just connect to it with DRATs, and you can chat with other people and send messages back and forth and files, and basically practice what you need to do without a radio or over long distances or whatever. It's pretty handy, and you can link your local RF, if you'd like, to the RATflector so that your local RF users will see the RATflector users and vice versa. And Debbie, N9DN in Chicago, or not Chicago, but Illinois somewhere, Champaign-Urbana, holds a net. I don't know, do you know when it is?
Tuesday nights at 8 p.m., except when the club meets, then we go up to Wednesday.
Okay, so Tuesday nights at 8 p.m. sometimes.
3 times a week, 4 weeks.
3 out of 4 weeks, yeah. So she has a net there and checks in both RF users and internet users. So if you're on around that time, that's kind of cool. So these are the two. Oh, that's both port 9000. That's not good. That should be 9000 and 9001. There's two RATflectors. There's really no need to have two of them anymore. It used to be one for RF and one for internet. But anyway, if you download and install DRATs fresh the first time, it will automatically connect you to the first one. And if you already have it installed, you can just create a network link for that, and you'll be online. There are user-run RATflectors. There's several people that run them. Like Debbie runs one when she links in her local RF people. So you can run one too, and you can link it to the big RATflector or not. This was yesterday, but I did something for the last month. So about a month ago, I started a bot on the RATflector collecting unique call signs to see how many unique ones we could get over the course of a month leading up to Dayton. And when I got on the plane yesterday, the number was 487 in the last month, and this morning I think it was 513, which is way larger than I thought it was going to be. But anyway, so that gives you an idea of how many people just have used it in the last month. And you see people on there from Italy and Brazil and all over the US, so it's kind of interesting. That is my map for maybe the last year of every station, not every DRAT station, but every DRAT station that's actively either gatewaying or broadcasting their position. So that gives you an idea. There's a lot of people from all over the place. And this has always been here, but it runs on Windows, Mac, and Linux. It's written in Python and uses OpenStreetMap maps. So hopefully that covers just about everybody. I think it probably would run on Solaris if you really cared, but so it should be okay. And we've always had a Windows, well, not always, for a long time had a Windows installer, because that's how you guys do things. But it is. Right? Mike, N0SO, is in Missouri, I think, and he creates and maintains for me the debs and RPMs for Fedora, Red Hat, Ubuntu, and Debian, and helps keep the repositories updated. So if you run Linux, you can just add the DRATs repository and stay up to date, and it's really easy and nice to install. And if you run a Mac, I'm sure you don't have this on there, but there's a .app now, which is really nice. So it used to take about a day and a half of compiling everything from a typical Linux system on your Mac to make it run. So now there's a .app, and you just download it and double-click it. And most Mac users can figure it out. So probably. All right.
So my name's David Lake, G4ULF, AF6WW. I think I've spoken to a lot of you on various reflectors and repeaters around the world. Hope you can hear me okay at the back. I want to talk to you about a homebrew D-STAR repeater that I've built. It's taken about 2 years. I just want to explain how it's put together, what the components are. Hopefully, I'll do a demonstration, but given the, how things have gone so far, who knows? But if the demonstration doesn't work for some reason, stand 96, 97, stop by, and we've got the system up and running up there. So what were my initial project goals? Well, I wanted to build a homebrew D-STAR repeater. I didn't want to use anything from any particular manufacturer. I wanted to connect it to the G2 network, and I wanted to connect it to the worldwide K5 TIT run G2 network. I wanted to connect it to DPLUS, I wanted D-STAR monitor, and I wanted anything else that you could think of. And I wanted it in a way where I could just take that code, not have to go back to Robin and say, hey, Robin, can you compile a special cut of code for me? Or to Brian and ask him for a cut of code that would run specifically on my hardware. But I wanted to run exact same software that you would find on a G2 system. So that pushed me to Linux. Now, the last one is very, very important here. If I explain some of the history, I'm a member of a group of amateurs in Crawley in West Sussex, hence my slightly strange accent, sorry. And we have a site where we have a 440 repeater. We have excellent access to the site. We have excellent coverage from the site. But the one thing that we don't have is money. And we looked at the price of how we could do this. We wanted to do something new. We wanted to do something innovative, and decided that the only way that we could go down this path was by going homebrew. Site is GB3 and GB7MH. GB7MH is on air. I'll talk about that. I'll show you some pictures of the repeater site. It's got some slightly unique features. And there are two new 440 megahertz FM and D-STAR repeaters for Crawley, West Sussex, which is about 25 miles south of London. Now, we have FM and D-STAR. I'm not going to go into anything about FM and D-STAR, but let's just say we have one site, two repeaters, and maybe in the future we could look at some interesting technologies and innovative ideas that we can do with those two sites. So what does the repeater consist of? The repeater that we have at GB7MH is built around a Tate T800. Now, a number of people have stopped by this morning and said, why are you using Tate? Why, can I use this radio? Can I use that radio? I'll explain in a minute why we're using the Tate, but I'll also explain the other things that you need to look for if you want to do this yourself. If you want to build your own homebrew D-STAR repeater, what do you need to look for in terms of a good piece of repeater hardware? This board is probably familiar to a lot of people. This is the Satoshi Yasuda GMSK USB adapter, modem, whatever you want to call it. It's a modem. You take analog audio in on one side and you produce 12-byte frames of USB on the other side. I initially started with the V3 firmware, and that was interesting. Very quickly moved on to what's currently supported, which is version 448.1L, but also now version 6, and in the booth we've got version 7 running, which is a very nice design. I'll show you that in a minute. And to run all this, what I've built this around is a mini ITX system. Again, come back to the mantra, don't spend any money. So I'm looking at very, very cheap systems that you can go and buy on eBay. 8 gigs of solid-state disk. I wanted to put this in a repeater site, so we need to keep the maintenance down. We need to make sure there's nothing that will fail in there in terms of disk drives, fans. So this is a fanless mini ITX system. 512 megs of RAM is what I found around. I have had it running down as low as 256, but 256 is a bit low. And CentOS 4, CentOS 5. Good, solid operating systems that don't crash when you're trying to do a presentation in front of several hundred people. and you need an internet connection. So let's look at the radios. What needs to be special about an FM radio in order to connect it into a G2 system? You need a flat audio response from the outside of the discriminator right through to the audio coming out the back of the system. Most of the radios that I've tested will do this. I've even gone to radios from a certain manufacturer that starts with the letters IC and used one of their commercial radios. That was the most difficult radio to convert to run on GMSK. They had 5 high-pass filters in the audio line from the discriminator to the output of the audio out of the back of the OPC 1697 cable. And it took me nearly 3 days to go through and cut the capacitors out and put links in. On transmit, you need a clear audio path. You need to be right down at very, very low frequencies to make sure that the GMSK is going through, and you need to be absolutely flat right up to about 3 kilohertz. Now, also coupled with that is this weird concept of dual point modulation. If your rig is synthesized in any way, you must make sure that the phase lock loop is not trying to overcompensate for those low frequencies that exist within GMSK, because they will see that as phase noise. So what happens at that low frequency is that the synthesizer will try and compensate for anything that's happening at the low end, and you will start to lose the integrity of the data, of the GMSK data, down at those low frequencies. It has to be flat, from very, very low up to quite high. And I found one commercial repeater so far, which luckily I don't think happens to be around in the US very much, but is unfortunately in much of Europe. And that's the Nokia or Key Systems BSR 450. The times that I have had this radio apart, playing with the phase lock loop filter, trying to get that response down low, you wouldn't believe. My wife wonders what I'm doing in the garage most of the time, playing with capacitors. Let's not go there. It just does not work. The only way that I can deal with that is to redesign the synthesizer and go to maybe a dual point modulation. Look for rigs that have dual point modulation, such as the Tate T800, or look for a radio that's already specified to work on packet mode, 9600 packet mode. Most of those radios will work absolutely fine with no conversion at all. So what have I tested so far? Well, the Tate T800 is my favorite. We've had loads of those available in the UK at about £199, which at one point in the world started off at about $300 and is probably now, I'm afraid, more like $199 given the exchange rates. We don't have an economy anymore. The Tate radio modems that I've got over here, I'll show you those. They are great. They've traveled all over the world with me and acted as a repeater. That's what I've got showing at the booth. Tate TM8100s, you may notice a bit of a theme here on Tate. We had some spare Tate equipment, which I just happened to find a home for. The TM8100 is a 40-watt car-based unit, great radio, absolutely solid, and works very, very well on D-STAR. Absolutely cool on 100% duty cycle as well from transmit. It's a beautiful radio. And we've got the ICOM ICF210S working and all that range of commercial radios as well. My favorite one is the FT8700 and 8900. Packet port on the back. You can connect that straight into the Satoshi board using the mini DIN connector. That just works. I've even had the repeater working in my car with the FT817. And just about anything else with this packet port running at 9600 should work fine. What does the Satoshi board do? Okay, so the Satoshi board takes your audio level, your audio in from the rig, and converts it to a GMSK baseband replica. It is not true GMSK modulation because you're not Gaussian minimum shift keying the oscillator or the PLL or the synth within there, but it is a representation of that, and it works very, very well. In reverse, we take the FM signal, so we're taking the audio coming from the radio and converting that back into data across to the USB port. You can see on this sign we've got the GMSK modem here, which is a CMX589 GMSK chip. There's a PIC here which does all the data handling. This converts it from the GMSK and puts it into USB format. This particular board has a second PIC that allows you to operate as a full standalone repeater. Satoshi doesn't allow you to do that so much anymore, but that exists if you want to run without an internet connection. And these things can be built for around about $50. Alternatively, you can phone CML microcircuits up and say, can I have some samples of your CMX589? And when they say how many, you answer 10, and 10 appear. These chips will come in at about $20 to $25 each. You'll notice in there is no decode of the audio. I am not touching the AMBI data stream at all. I'm taking that, manipulating it, passing it into G2, into DPLUS, but there is no need to put the AMBI 2020 chip in there to decode the audio. Satoshi is currently selling these units fully built, this one here, at about $120 shipped to the US. What does the software do? So I take the data off the Satoshi board, take it through the USB, and I manipulate it within the code. There's basically several elements to the code. The first and most important one is the G2 database itself. This repeater looks and feels like an ICOM system. As far as K5TIT are concerned, it is an ICOM system. It's registered in the same way to the K5TIT trust server. You can G2 route in the same way that you can on an ICOM system. You have the same ability to add and delete users. Yes, the admin interface is different. We had to write that separately. But there is a Postgres SQL database running within the software that you interrogate in the same way that ICOM do within the gateway. It includes all the features of the ICOM software with one exception. I haven't implemented multicast routing. I'm still trying to decide whether I want to do that or not. One of the reasons for that is when we originally put this in, I had very, very limited bandwidth to the repeater site, and I didn't want to get into the position where I was overloading that bandwidth. And each system, as I say, as far as K5TIT are concerned, appears exactly as if it was an ICOM system. It's registered the same way, the users appear the same way, everyone's on there. The next piece of code is this lump of code that I call the DSM code. Now, in an ICOM system, you have a controller sitting on one side, you have a piece of Ethernet, and then you have the gateway. So between the controller and the gateway, there's some communication going on there. And people like Robin, people like Brian have hooked onto that messaging to enable you to run extra programs like D-STAR Monitor, DPLUS. I've emulated that code so that all those messages that you would normally expect to see happening on that piece of wire between the two systems are still there. Upshot is that anything that currently runs on an ICOM system will also run on this system. You can take DPLUS, you make one change to one of the config files, and it works absolutely perfectly. D-STAR Monitor reports through DPRS. I get all the scripting information. Brian can add, delete call signs as they do from time to time. It works without modification. There's then the G2 repeater code. This is the same code that allows you to talk through the box. You set your RPT1, your RPT2 in the same way. You get the same messages back from the ICOM system. So you get the RPT question mark when the call sign isn't found in the local database. You get the UR when the call has been routed across the network to the distant side or when there's been some other failure. You get all the same information back. So if I key up on the repeater and I haven't said RPT1, I haven't said RPT2, it'll bleep at me. It'll set them on the 92 anyway, in the same way that you'd expect from an ICOM system. Now, what else have I done in the G2 repeater code? There's a lot of things you have to do with voice over IP streams to make them sound good when you play them back out. So DPLUS is great. It's got sequence numbers. You know when you've missed a packet. You know what's coming next. G2 isn't like that. G2 doesn't have sequence numbers. It has a rigorous sequence. It has a 21-byte sequence, and it sends 552D16. That's sad that I remember that. 552D16 every 21 bytes. This is my sync frame happening. I have to send that every 21st frame. If I don't send that, I get a beep from the radio. So I have to make sure that if I've missed those packets and if the timing's not right, I'm infilling with silence. Now, silence is a specific sequence of 9 bytes of information that I have to infill. So I'm doing that. I'm also de-jittering. I'm smoothing this session out to make sure that I am sending frames roughly every 20 milliseconds to the USB port, that the radios are going to have a nice, smooth response of audio coming back through. I am not even going to begin to try and explain how many hours that took to do. I must have been about 21, I think, when I started this. I'm not anymore. There are a couple of unique features within the software. So the first one that I did was I added a dual mode ident. So every 7 minutes I get an ident coming over saying GB7MH repeater, but included that on the 14th minute, so on the alternate 7 minutes, I get a message come up. What I tend to put in there is something like location, locator code, GPS information, that kind of thing. You can program a message in there. So if you wanted to, you could change that message today to say the repeater was on low power, or that the repeater was going off at a certain time. I just thought that would be quite useful to have. The other area that I was quite keen to do, and Robin mentioned this just now, is that I wanted to include some kind of information back to users to tell them that they were linked to a reflector, or tell them that they were linked to another station, another repeater. So when you get the RPT question G coming back from the repeater to say that the call sign hasn't been found in the local database, I include a text message with that. And that text message is either linked, and which reflector or repeater and port you're linked to, or unlinked. Very, very simple, happens every time you transmit. So there is no excuse for stamping over people because you didn't know that you were linked. I find it very, very useful just to find out, to work out where that is. And of course, the voice announcements that exist through all the other scripts, exactly the same. You can keep those running. Because I'm at a single Ethernet, I don't get into the same issue that you may get with other manufacturers where they insist that you have 10.0.0.2 on a Class A subnet. Why? You don't need that. I have a single IP address, unfortunately a public static IP address. I'd love to be able to change that, but the database just isn't built like that. And you can have a single IP address for your entire repeater. There is one Ethernet port that connects to the outside world. You don't have to start building two connections. You don't have to start building gateways, controllers. I'm a simple person. I didn't want to go there. User and admin pages. I've tried to keep the look and feel and the basic way that the user and admin pages work. So you still, as a new user, you have to go in and register yourself. The admin has to log in and authenticate you or authorize you. Then you get access to G2 and DPLUS. But one addition that I've put on there is the ability for the admin to log in and add a single user. So I was getting very annoyed with having to go onto the system, add a user, log back out, go in or authorize that user again. You can go in and just put a call sign in G4ULF or authorize, and that will immediately go onto the system. At the moment, I'm working on another feature which says how many users do you want to add. So I've got between 1 and 99. It then draws you a box of up to 99. You put all your call signs in, hit the button, and they will all go through and be added, authenticated to the system immediately. Not quite there with that. There's a wonderful bug in that stops HTTPD at the moment, but never mind. And there are other features that I could put in there. So one of the things that I've been playing around with is LDAP. Can I report user location back using LDAP or some other directory structure, dynamic DNS maybe, external SQL database? Maybe we can start to do things that link the current G2 system to a new way of creating a database. All work in the future, maybe if my PC doesn't crash on me too much. Cost. I wanted to keep this cheap, so I've spent no more than £50, $75 on mini ITX systems. I tend to buy them off eBay. I've been lucky. I've only had one dud so far. The solid-state disk, you can buy 8 gig solid-state disks for something between $45 and $50 these days. They're coming down in price. And I'm not using conventional power supplies on these. I'm using 12-volt Pico PSUs, the idea being that I've got a repeater site with 12 volts. So why would I put a 240, or in our case, supply in that costs money, that wastes power? I wanted to keep the power factor. I wanted to keep the load, the total load, and the footprint of this very, very low. Metalwork. People will tell you from the repeater group just how bad at metalwork I am. But we're looking at about something around $180 for the entire repeater systeming. The main database as well, in terms of footprint and weight, in terms of code, is very, very small. If you've delved into the ICOM system, there are some quite large files in there. I've written everything in native C++. Again, I'm a very simple person. I only ever program to C++ sockets, if you know that. Ask me to do anything in GUI, no time at all for that. And I'm down at about 80 kilobytes of code compiled for the entire system. So you don't need a lot of space for this. The database is what takes the space. We've got some user and admin pages. They've been written in Perl. And again, I think they weigh in at about 250 kilobytes maximum of code. Very simple, quite intuitive to use. And what it means is you can get down to a very small portable repeater. This isn't a particularly good photo because it doesn't show how small that is. That box there, that PC there is actually this one. It's my netbook. This was the repeater running at a hotel in Manchester in the UK called 11 Didsbury Park. Sitting in the bar, talking to someone that you may know, Darren, G7LWT, if you've heard him on Reflector 5A. He's one of the people that seems to be up 24/7 fixing problems on D-STAR. He and I were playing with this in the bar one evening, just seeing what we could do. I was using the hotel Wi-Fi. It's great. It's just running in Linux on a console. Although I've got it shown here running with a Windows session, you don't need to do that. In fact, again, I'm a CLI person, I'm a command line person. I like to put everything down on command line, keep it very simple, keep it as an appliance. And that's built with 2 Tate radio modems. I'll show you those in a minute. A version 7 Satoshi board, my Asus 901 running Ubuntu, because it's a stable operating system. 3G connection to the internet, and this has traveled with me everywhere. So I've been to the UK, I've been to the US, I've been to the Netherlands, Belgium, Spain, Italy. Unfortunately, I wasn't allowed to take it to Bahrain. They're not so keen on radios there. But everything here has been working. And you can get into some interesting things because this is running things like DPRS and D-STAR monitor. So 2 weeks ago, this was sitting in Milpitas in California. And I worked this wonderful QSO to a repeater called N08i, which is this one. I'd set this was the one that I was going to set up here. I set up the coordinates on D-STAR monitor and put my GPS mic on the IC92. And I forgot that I'd be transmitting GPS information. So I went and looked at aprs.phi and put in my call sign there to see what the path looked like. And look what we did on 440. I mean, that's great. With 1 watt. So very quickly about GB7MH, our repeater site. It's in a church. It's one of the highest churches above sea level in southern UK. It's 174 meters above sea level. It's a great site. Can you see any antenna on that building? There it is. It's in the flagpole. So that is a fiberglass flagpole that conceals a 2 meter and 440 collinear. The repeater group, some of whom are here today, have spent years and years negotiating with the local community to put up. There is a flag that flies on that quite frequently. It doesn't seem to do anything with coverage. That's great. We're fine with coverage on that. But that is our repeater site. The repeater sits in a cabinet inside the bell tower, and we've got a couple of bells alongside that. It's a great location. It's open 24 hours a day. We can go in there, provided we're careful, and start servicing the repeater. So did the project achieve what we wanted to do? We've been on air now since September 2009 with coverage of about 80 miles distance from the repeater. The flagpole and the installation cost us a fortune. I'm not going to mention how much it cost. It cost a lot of time, a lot of persuasion, and a lot of money. But the system itself, the D-STAR system, cost about £250. This is a lightweight software stack. It's very easy to maintain compared to some other manufacturers that I could mention. And it is truly in the amateur tradition, I think, that we used nothing for its original purpose. We modified everything. And that's what I like, that you change everything. Nothing does what it should. Great. My wife hates it. But we changed all this, and it works beautifully. And I can only just say thank you to the other members of the repeater group if they're here. These people have spent hours and hours and hours acquiring and fixing this site. Some other systems working now. We have GB7BM, which is the first beta site in Birmingham in the UK. NM, we've got one in Sweden that I can't pronounce, another one in Finland, which I'm not even going to try. Another one in Staten Island, which went on last week. That's a good system. I've met the owner here today. He's spent many hours. A couple more to follow. And the interesting thing here is you can also change it to a simplex G2 node. So MB6AM, sitting in the middle of the UK, is a G2 D-Plus system that you can call sign route to. So not just actually doing simplex operation, but you can actually locate a station on there, it runs the same software. These people have done a fantastic job. The K5TIT team spend all day, every day supporting this network. They have been brilliant. Thank you so much for letting me play with your network, both live and test. It's been great. And if you want to come and see the demonstration, we're at stand 9697. It's on 443-600-5. Has a repeater ID. It's sitting here. I'll just show you very quickly. So this is the netbook running the software. I've got my air card sitting in the side. Oh, I've got someone transmitting at the moment. I've got the red light up on transmit. That's the Satoshi board, the version 7 Satoshi board. And this is my transmit and receive radios sitting over here. And with a bit of luck, oh yeah, there we go, AE0. Let's see if we can get someone just to come up very quickly. Oh, he's all R2D2, great. Let's unlink it to show you that it's exactly the same. So I put U in my call sign.
Not currently linked.
Okay. And then we'll link it up to 30B. Basically, when users drive into range of this system, they have no idea that they're not on an ICOM system. It's exactly the same. That's, there you go.
Our time's about up, David. So.
Yep. It's my website on the bottom there. If anyone wants to get in touch with me, I am pretty difficult to get in touch with, but please keep an eye on what's going on. Yeah.
David, I apologize for coming in late to your thing. I didn't know if there was a forum going on, but I have a question, and they said you're the one that could answer it. Somebody is developing a module that would allow my IC7000 to do D-STAR. Not as a repeater, but as a D-STAR transceiver. Am I correct or incorrect?
There is a module to do that. So Satoshi built a module to do that. I would only say that you should attempt to do that if you are very good at soldering 168-pin AMB 2020 chips. I've done 2 of them, and I have promised that I will never, ever solder one again. They are incredibly difficult to do. I actually bought 4 chips, broke 2, and so yes, you can do it. There is a station in the UK that runs an FT857 with a board. You do need the user interface to be able to set RPT1 and RPT2. I'd think very carefully before doing it.
Well, I hate to cut this off, but we do have to go. Gary Pierce, N4ANQ, is videotaping this forum and other D-STAR forums. Look for him on the web. Thank you guys for your presentations.